we use the word strong and weak. The strong bases are actually ionic compounds, and so they would form a base when they just ionize, when you break the ions apart. So when you do the ionization of lithium hydroxide to form lithium plus hydroxide, that's a strong base because it forms hydroxide. Because a base is a substance that will gain an H plus and it forms hydroxide, which is OH -1 in water. So we're just showing a weak base dissociation in water. And so our weak base is going to take a hydrogen from water. And if water loses an H, then it creates hydroxide. So here's the general format. Your base, whatever the formula is, will be written aqueous because it's already dissolved. And then you'll put plus water, and this will be the water molecule that interacts and gives up an H to the base. So you're just showing one water molecule because it's just an exchange of one hydrogen from the water to the base. In order for this to happen, the base has to have a pair of electrons, and it uses that pair of electrons to take the hydrogen and bond to it, and water gives that hydrogen up. And so when water, which is HOH, if you were to take an H off of it and it left its electrons behind, you would end up with OH and that extra pair of electrons, which is that OH. So it would be water, and the base is going to take that hydrogen and it will leave OH, and the hydrogen leaves the electrons behind. So that's where the negative charge comes from. So again, these are just weak bases. All the strong bases are ionic compounds. So all of our weak bases are going to have a pair of electrons somewhere. But because we're just going to write formulas, you're not going to see the electrons. But you got to think back to how you drew molecules and the kinds of things that had lone pairs. So if something has a negative charge, there's a lone pair somewhere that gives it the negative charge. So oxygen would have an extra lone pair. Nitrogen always has a lone pair when it has 3 bonds. Any anion has lone pairs because they're ions. And so the base will use a lone pair to bond to the hydrogen and take it from water. And it can do that because bases have the ability to turn intermolecular forces into actual covalent bonds. Not strongly, but weakly. So equilibrium. Equilibrium means a little bit of this happens, but in water, you would see the base, whatever the base formula is. You would also see what's called the conjugate acid form, and you would also see hydroxide. Hydroxide is what makes the pH change. Bases have higher pHs because they have hydroxide. Okay, so here we have this example here. This is an organic substance, methylamine. So nitrogen forms 3 bonds and has 1 lone pair. And so I'm just going to draw the lone pair onto the nitrogen. That is where the hydrogen goes. So this is our weak base. I'm going to put WB for weak base. Water is actually HOH. Might help to realize it's not H2, but HOH. So a base will accept a hydrogen to form hydroxide. So right there is the hydrogen that it takes, and it will go on to the nitrogen. So if nitrogen has 2 hydrogens and it takes on 1 more, it it gets 3 total. There it is. It will absolutely not go on to carbon because carbon doesn't have a lone pair, it has 4 bonds. So you do not put extra hydrogens on a carbon. So you want to look at your formula and you want to find the thing that's not carbon and give it the hydrogen if it's organic. And most of these are going to be organic because most weak bases are organic or they're anions. So that's where you get this. Because it gains a positive, then all of our base formulas will change their charge by +1. So if it's 0, it becomes +1. If it's -1, it becomes 0. So whatever the charge is on your base formula, it'll change by +1 because it gains a positive hydrogen. And then the water becomes hydroxide. A base accepts a hydrogen and forms hydroxide in water. Okay, so if you look at these, this is an anion. All but 8 anions are bases, are weak bases. The 8 that are not bases are these anions. These are not bases. The anions take the hydrogen off. Those are not going to be bases. Every other anion is actually a base. And so if it's an ion, then you just add a hydrogen to it. But if it's a molecule, where would you put the hydrogens on these formulas when you make the product? You would add them to the H's that are part of nitrogen. So this doesn't show the structure. This is the condensed. But you should not put them with carbon. So this is condensed. So whatever is right after the nitrogen is what's bonded to it. So don't add it to carbon because that would give that carbon 5 bonds. It would give that carbon 5 bonds. It would have to go on the nitrogen. And this, it would go on the nitrogen. Okay, that's just an ion. So it would just go on that one. So every single one of these, you would just write that formula plus water. They're all weak, so they're all equilibrium. And then you just give this formula an H and rewrite it. And then you write hydroxide. Okay. So when you're studying these, keep the general format. And then I recommend that you label things underneath it so that you can keep it straight, so you don't get confused. Because next week we're going to take these and we're going to do, these are going to be the start of an ice chart for us. And then we'll calculate pH. But you have to have the dissociation. And then equilibrium, there's an equilibrium expression and an equilibrium constant.